So I think everybody's already had a bit of a sneak preview of this one. My confession at the beginning was that I'm not a data scientist. I'm not a digital technical person. I'm an architect, not a software architect, an actual architect who designs buildings and cities. I work for a company called Space Syntax. What I'm really going to talk about is a bit of overlap actually from the last talk, understanding things around causations and correlations, unpicking this really important question about not just what's happening, where and when, but why does it happen, and using data to answer that. And if we can do that, you can better understand what's happening, we can put conditions in place to allow positive outcomes to happen. Here we go. So Space Syntax, we're a SME spin out from the Bartlett about 35-ish years ago now. We've got 5 streams of activity: studio, where we lead design teams. We do consultancy, where we work with other designers and support other clients. We do training, research, and we have a digital stream that looks at providing digital outputs. So what we're really interested in is this sequence that I think probably people have seen these stories a lot over the last few years, and you see them in the mainstream press all the time. That's actually quite an old example there. That's 2018, but it's been same story has been in The Guardian at least a couple of times this year. People moving into new houses, being really unhappy they have to drive everywhere. Next part of this is more and more medical research, starting to relate the activities that you do every day, how much you walk, to health outcomes and health impacts. And I think that, again, that particular study is 3 or 4 years old. There's more up-to-date research finding different outcomes or stronger relationships. But this was talking about even people that take public transport to work have a lower risk of obesity. And we know there's research that starts to link those small individual impacts have a much wider impact on society in terms of things like days lost to sickness, but also in terms of things like climate outputs as well, climate impact. The really important part, though, and the bit that we're really interested in, is the way that we can model the built environment. So we can take data on cities, the big fixed bits which change really slowly, and we can analyse them before they've been built. And we can see if places are car dependent. So you can move away from this kind of trial and error approach to urbanism, which seems to be what's happening in this sequence here, and we can start to see if places are car dependent before they've been built. That then hopefully means if you can explain why you've made it car dependent, you can avoid creating those conditions in future, and you can start to change this sequence. Health is probably everybody's aware in here. Health is a really good example, but a really bad example as well, because it's so complex. It's really horrible because there are things which are to do with individual characteristics, to do with age. You might inherit a certain condition. You might live a certain lifestyle. So to be able to see a link between some of these things and an outcome is really, really difficult. But this was the Government Office the Government Office for Science Foresight Group put this obesity systems map together. They started to categorise everything in here. And the bit that becomes really important is there are a whole load of socioeconomic or demographic factors which are in here, but a big part of this is also the built environment, is the physical activity and environment. So there's this really big complex puzzle, but there is at least one part of it that we can work with and we can start to change. And you might change that one bit. It doesn't mean you can guarantee a positive outcome, but you can make it possible. I think the story that we're seeing at the moment in the UK is that a whole load of decisions are being made which make those positive outcomes almost completely impossible. So the way that we start to do that, we have this thinking, we had that sequence that was there earlier. We can talk about the built environment, we can talk about the big fixed physical bits, street networks, land uses, density. Within that set of physical systems, there are also things like transport services. They can overcome or they can mitigate some of the conditions that the built environment has fixed into it, but they might create their own constraints. There might be constraints around cost or practicality, or there might be times when people can or can't travel. There's people's perceptions and whether they think it's easy to walk or difficult to walk. All of these things impact behaviour, the activities that people go through, and then we saw how that has these longer impacts on the individual and on society. Now, one way of starting to think about this is to think about that part of the built environment, that one part of the kind of complex jigsaw, to think about it as quite a simplistic kind of science experiment where you have a set of variables, which is the things that you can change. So that's your street networks, your transport, design of the public realm, and you can look at your result. And we have lots and lots of data that talks about the result of activity. So we can see there might be data that's coming from sensors, from phones, from bikes, lots and lots of things that will be telling you this number of people are in this place at this time. That's really helpful. It's really useful information because you can see that something's happening. But the part that becomes really important is to explain why it happens. And if you haven't got the data on the systems to see that the spatial network creates this hierarchy that means that this is the best connected street that everybody's going to use at this time, and there's a certain density of population and a certain density of employment at each end of it, it means that if you don't have the information that can explain those systems, trying to change the results which are happening is really, really difficult. So we have the data on the what and where and when, and what we're really focusing on is the data on why and trying to explain some of those things. So the way that we've done that as a company is that we have developed what we call integrated urban models. So that's building on the spatial network description of the city using a spatial network and linking other data to it. One of the things that becomes interesting is when you compare it to kind of more traditional ways to describe the built environment, and there are certain problems which are built into it. People probably recognize these images which were in the Urban Task Force report from, it might be more than 20 years ago now. But density, a bit like health being an interesting example, density is quite a good example of this, that all of these three examples are the same density, but they're all arranged in completely different ways. They've got different numbers of front doors, which means that there'll be different amounts of activity happening on the street. The network of streets is completely different. The distribution of green space is really different. Where traffic can and can't go is completely different. So if you're only looking at density as a way of explaining the built environment, there's a whole load of elements that are going to be missing from these characteristics, as well as the fact that it depends a little bit on where you drop your area that you're measuring. So the way that we have been getting around that is through using integrated urban models, taking the street network, being able to take centerline data, analyzing the hierarchies that are within that, linking that to land use data, to density data, taking public transport timetables, turning that into a network model and linking everything together all at the same time. What that then means that we can do is we can look at towns and cities from the perspective of a person and looking from the individual building to say, this example here is something that we made which is a walkability index. So what this does is it takes for every house, it takes all of the land uses, sorts them into families, and it starts to analyze how many of those land uses can you get to if you're walking, how many are there in each family, what's the distance to the closest one. So red is more walkable, blue is less walkable. So we have this consistent way to describe the built environment. I'm going to speed up because I can see that there's only 4 minutes left. Last year we did a big piece of work. We took the walkability index from the whole of the UK, and we wanted to see how does that relate to mode share. So we took census data. We looked at, first of all, a big piece of data exploration, looking for relationships between certain characteristics like age and income. But what you can see here is the really quick summary of this is that there are correlations between age and walkability. Most walkable parts of a city tend to be the centres. What you find is that actually there's a very narrow section of age ranges that live in those areas. And there's a whole load of reasons why that might be. It might be about housing policy, or it might be about family size, or these sorts of things. There's lots and lots of other questions that come out of this. Second part is that you can see in the bottom bit, you get bigger houses tend to be in the places which are less walkable. They're less walkable because it might be the typology of housing is bigger, they have gardens, the distances between things then become bigger, so the density is lower, so the distances between everything increase. So there's a whole load of typology and policy questions that come into it. As people tend to get older, the places where you have higher levels of people over 45, you get multiple car ownership per house. So you can see this really strongly in this top graph that you get a really strong correlation from 45 to 59 owning 2 cars per house. So there's lots and lots of these things that we can see. Now what we did was we combined a whole load of socioeconomic data with the walkability index. We made a model that could explain mode share across England, so across the 330 local authorities and the 7,000 MSOAs. What we found was that there were elements where places where you got more people walking had higher populations of people between 18 to 29. People didn't have children. That's interesting, but if you're a local authority and you want to get more people walking, you can't really change the number of your households that have children, or you can't change the age of people. The thing that was really important in this was that the third really significant element in the model was the walkability index. And that's That's the built environment which people have control over, you have some impact over as a local authority. So the next piece was then to say, okay, what is it that makes it really walkable? So if we zoom in on this, we can start to take parts of the city, and if we start to look at the scatter on the right, we've got the y-axis is the walkability, x-axis is the block size. The most walkable bits have a facade length of no longer than 50 to 150 meters. So you can start to say there are smaller urban blocks which make it more walkable. It's really important that you don't just concentrate on how something works at a very small scale, but what's also really important is how they fit into a bigger network of space. The other characteristic of the walkable areas is that they're part of a bigger network. They're not just isolated on their own. So these smaller, more walkable human scale blocks are in a more connected street network that gives between 3 and 5 streets to connect into each time. So the way that we can take that, we can learn from the places where people walk. We can then use that to design new cities so that you're building in the conditions that make it possible for people to walk. You can make it possible for those positive outcomes to happen. So this was an example of a master plan project. It was a competition entry that we did for the capital of Kazakhstan back in 2017. That won the competition. That whole strategy was based on improving the existing city, intensifying the existing city, and then growing it. And this was the part of the proposal that was about growing it. When we did the project in reality, the population forecasts were lower, and we spent a lot of time improving and intensifying the existing city. That went on to win a couple of awards. The other way that we can use these tools as well is that you can start to see where the built environment makes something possible, where it's possible for people to walk, but it's not matched by what people are actually doing. And so there's a whole range of different opportunities to do things. It might be that you can't physically change the city. You might not be able to change your infrastructure, but you can at least start to profile it, and you can see where things are possible. You could then start to target or change. You might be able to do a behavior change campaign, or you might engage with people in certain areas. So that is a really quick summary of the way that we use data and try to deliver positive outcomes through our work. Thank you. Oh, yeah, okay.
Yeah, that's fine. Anybody have any questions for Ed? This gentleman here, if we can get a mic over there, that would be amazing. Thank you. Just put your hand up again so that Dario can find you. There we go.
So yeah, which cities you found the most walkable in the world, in Europe, and how walkable London is?
What's really interesting is when we were looking at England and the UK, there were some really interesting findings. One was to do with the size of the city. There were places like London was really interesting because we had different measures of city size in there, which was to do with the basically the intensity or the density of the street network. What we found in places like London, it had actually a lower level of walking than you would expect, but it had much higher public transport. It becomes really interesting if you look at not just things like public transport, but if you look at car ownership. Car ownership across London is really, really low. I think part of the reason for that is, there'll be elements about once the city gets to a certain size and certain density, you can support public transport. But it also means that once you get above a certain size, it's much more difficult to walk because the distances are too far. So London's a really interesting example because actually, if you look at the places which could get a higher level of walking than they currently have, lots of them show up, but it tends to be the outer boroughs. You do find as well across London, you get much higher active travel as well as public and as well as lower car ownership. We did do an exercise where we were looking for those mismatches, and a lot of them came out being in London, but they were kind of exceptions, I think.
There's another question there at the back.
Thank you. Yeah. So, in your research, have you found any kind of shorter-term solutions to make cities more walkable? Because I'd love to flatten the kind of suburby area I live in and make it more walkable, but I wonder if there's kind of quicker ways to do this kind of change that you've thought about.
I think one of the things is that you have to coordinate a whole load of different interventions with each other and over time. And there are things that you can do in the short term, which might be where the things are already in place. it's a dense grid, the land uses are close together, the public realm is good. There are also places that aren't walkable, and you might think about the way that growth is allocated in future. If you can see that they're naturally part of the location of places, is they're closer to things and more central. But you can also start to explain some of the physical characteristics which are missing. It might be that if you take the suburban example, that you might be able to change it, not overnight, but you might be able to change it in the shorter term by diversifying the land use mixes or being able to pick out what's missing from those areas. But one of the real core characteristics of cities is the way they work across lots of scales all at the same time. And that's really difficult it becomes quite difficult to intervene in them sometimes because it's this kind of complicated overlap of things.
And we can squeeze one last one in.
Hi, Ed. Fawad Qureshi from Snowflake here. So you mentioned about the built environment. So is the built environment like the digital twin as we refer to in the spatial industry, or could you expand on that concept?
So I think there's quite a good definition of a digital twin, isn't there, which is the link between live data coming from the entity and the model itself, and being able to have that live link so that you can change the model to change what's actually happening in real life. I mean, in one way, it's a twin because it's a representation of the city. It's just that to start to change it using some of the things that we're able to look at in the model, it takes time. So I'd say it's a representation, but in terms of that live link between being able to change a line in the model and it having an impact on real life, it probably isn't quite within that strict definition.
Awesome. Well, if anybody has any more questions for Ed, I think you're around for a little bit longer.
I am.
Fantastic.
Yeah.
So thank you very much, Ed.
Thank you.